Okay, we've gone through triangle congruency in chapter 4. Now we're dealing with special types of triangles. At the very beginning of the chapter, we classified them by their sides and their angles, and then we spent the rest of the time so far proving them congruent. Now we're dealing with two special types. We're dealing with isosceles, which, if you remember, was a triangle with at least two sides congruent. We're also dealing with equilateral, where, pretty simple, equal, lateral, the sides are equal. Not too tough. The way we introduce you into isosceles and equilateral triangles is by breaking down the different parts of the triangles. The first thing we see are the legs. And the legs are, in essence, the sides of the triangles. They're called legs because they hold the triangle upright. The two congruent sides of an isosceles triangle. The vertex angle is the next thing we see. And the vertex angle is the angle formed by the two legs, and it's at the top. Then we have the base, and the base is the third side. Now, every triangle has two sides going up and one that's the base. Maybe the triangle is on its side, and so it's, if it's sitting like this, sorry about that, there was an announcement. If we have a triangle like this, we still have a base and two legs, regardless of whatever position it's in. But there's the base. And then we have something called the base angles. And the base angles are just that. They're the angles that are formed at the base, the two angles formed by the base and the legs. So when you hear somebody refer to the base angles being 45 degrees, you have to be able to say base angles are right here. If somebody says that the legs of an isosceles triangle are congruent, you have to know what legs they are talking about. Same thing with the vertex angle and the base. Now that you kind of understand where those positions are at or what those parts are, let's talk about the theorems that kind of identify isosceles triangles. One of them is the base angle theorem. And it says if two sides of a triangle are congruent, then the angles opposite them are congruent. If two sides of a triangle are congruent, then the angles opposite them are also congruent. So in here we see that AB is congruent to AC. And because AB and AC are congruent, angle B and angle C are also congruent. And the reason for that is actually found using trigonometry. It's the study of angles. We get into trig a little bit at the end of the year. So for this, you're actually going to have to hold off on why that is. But just understand that because these two sides are the same size, the angles are also the same size. We have the converse of that theorem that says if the angles are congruent, then the sides are congruent. Notice the end result is the same. The end result is we have congruent sides and angles. One of them, however, starts with the sides and goes to the angles. The other one goes from the angles to the sides. And that's what that little note says. Not a big deal. Isosceles triangles. Isosceles triangles are not only isosceles because they have two sides congruent, they also have two angles congruent. That's basically what you need to know. Here we have a quick example, a little diagram over here. We're told if HG is congruent to HK, then what two angles are congruent to each other? We're told in the base angle theorem that if two sides are congruent, the angles opposite them, and by opposite they mean this. That. Those are opposite. If two sides are congruent, then the angles opposite them are congruent. Excuse me. Here we're given two sides that are congruent. Well, then you should be able to use the base angle theorem and say the sides opposite them are congruent. Or the angles opposite, excuse me. So we have angle HGK, HGK, talking about that angle, and this angle, which is angle HKG. If these two sides are congruent, then these two angles are congruent. Let's look at another example. Number 2 tells us that if angle KHJ, let's use a different color. If angle KHJ is congruent to angle KJH, then what two sides are congruent? And it's the exact opposite of what we just did. If two base angles are congruent, then the sides opposite them are congruent. So we have KH and KJ. Very simple stuff. Not too tough. Again, it's something new, so it requires a little bit of time, a little bit of focus. It's not something that just comes naturally, but it is stuff that you can master very quickly if you pay attention. Then we have two things that introduce us to equilateral and equiangular triangles. If a triangle is equilateral, then it is also equiangular. And what that means is, if we have three sides of a triangle that are congruent, then the three angles opposite them are congruent. Which makes sense, because in the isosceles triangle, we're given this. That if two sides are congruent, then the opposite sides are or the opposite angles are congruent. Well, if I just say that this side was also the same size as those, then the angle should also be the same size as those two angles. And so there I just went from an isosceles triangle to an equilateral triangle. This word equiangular, just write down here, equa meaning equal, angular meaning angles, equal angles. If a triangle is equiangular, then it is equilateral. If three angles of a triangle are the same, then the three sides are the same. If the three sides are the same, then the three angles are the same. We can break down the word equilateral too. Equa meaning equal, lateral meaning sides, equal sides. We dealt with these two words when we were dealing with polygons, where you had equilateral, equiangular, and regular polygons. It was something we covered very quickly. Here's where you're going to use it a lot more. If I tell you that something is equilateral and I give you the side length of 6, then you should automatically say, oh, if this side is 6, then that side is 6, and that side is 6. Or maybe I tell you that angle A is 60 degrees, then you should say, well, then angle C is 60 degrees, and angle B is 60 degrees also. And we'll get more in depth with that in our homework. Now that you understand the definition of equiangular and equilateral, use those two corollaries on the previous page to solve the following problems. We're told to find the measurement of ST. Well, something that I want you to notice right away is this. That in this triangle, we'll call it STU, we're given right away that three sides are the same, or are congruent. Well, the corollary just told me that if three sides are congruent, or the triangle is equilateral, then it is also equiangular. So, what I'm going to do is I'm going to say that ST equals TU, which equals US. Now, they actually gave me US right here and told me that it was 5. So I'm going to replace that with US. But if US and TU are the same, then TU also has to be 5. And if TU is 5 and ST is the same, then ST has to be 5. It's equilateral, meaning all the three sides are the exact same measure. If one of them is 5, then all three are 5. The next part is a little bit trickier. We're told to find the measure of each angle in STU. This one is a little bit trickier, and this one's going to require a little bit more understanding of your algebra skills. First of all, triangle STU equals how much? What is the interior measure of the triangle? I hope that you're saying out loud 180 degrees. Well, let's just say that angle S is x degrees. What do you already know about the three angles of this triangle? I hope you're saying out loud that they're congruent. And you're exactly right. If S is x degree, then T is x degree, and U is x degree. Well, now I'm going to replace STU with the angles that make up STU. Angle S plus angle T plus angle U still equals 180 because those three angles should add up to 180. Now I'm going to replace them with the variables that we gave them, and all three of them are the same, x. Now, 1x plus 1x gives me 2x. 2x plus 1x gives me 3x. So now I have 3x equals 180. Going from here to here, you can see how you need your algebra. Now, how could I solve for just x? Because remember, x represents one of these angles. Each x represents an angle. So if I can just find one of the x's, I'll find the other two because they're all the same. In order to solve this, what mathematical operation do I need to do? I need to do division. I need to divide because this is a multiplication problem. The way you undo or reverse a multiplication problem is through division. When you divide both sides by 3, you get x equals, and then 180 divided by 3. Well, 180 divided by 3 gives us 60. 60. If x equals 60, then each one of these angles represents 60 degrees. I want you to write down this little note. Excuse me. The angles of an equilateral triangle equal 60 degrees. Always and forever. If you're told that a triangle is equilateral, then every angle in that triangle has to be 60 degrees. If you find that a triangle has 60-degree angles on all three, then the triangle is equilateral. Remember this, that if you know all three angles are the same, what does that tell you about the sides? They are also congruent. And if you ever identify a triangle that looks like this and you're told that all three sides are the same, you say that's equilateral. And if that's equilateral, all these angles are 60 degrees. Equilateral triangles are fun because once you find one piece of information, you can find the rest because they're all the same. Isosceles are a little bit trickier, and skew triangles are obviously a lot trickier because all three sides are different. But that's it for Chapter 4. Dealing with not only the different types of triangles with their sides and their angles, but then dealing with congruent. And we learned 5 different congruency theorems that you need to know. And now we were introduced to 2 different, I guess we could call these types. We dealt with equilateral and isosceles. So that's Chapter 4 in a nutshell right there. Even though we're going to look at your homework for tonight, make sure that you're paying attention. Make sure that if you need a review, that you go back and watch these tutorials just to get a review of what we've covered in Chapter 4. Let's stop and look at your homework now.